So if we look at a couple other little situations here, we have a square that represents x plus 5 squared. Well, that's going to be x squared plus 5x plus 5x plus 25. So we get x squared plus 10x plus 25 altogether. And if we take this and think of it as negative, well, it still works. We got x squared, we got a minus 7x, and a positive 49. So x minus 7 squared, that would be this whole square, and that's going to give us x squared minus 14x plus 49. All right, so we can square binomials. Let's go the other way, and let's try drawing some squares now. What if we have a quadratic expression and we want to draw the square? Well, if we think about how these are made over here, we've got a couple 5x's. That's what gave us the 10x. So what would the size of this square be? Well, if we cut this in half, we see it takes two 12x's to make this. So in our square, we got a couple x's we know, and this right here is going to be 12, because that's going to give us an area of 12x and 12x here. And 12 times 12 for this little box down here would be 144. And there's our x squared. So we can see that x plus 12 squared is equal to x squared plus 24x plus 144. What if we have a fraction? Uh-oh, can we handle that? So we know we have x and x. What's the numbers? Well, it's got to be half of this 5. Half of the 5 is 5 halves. And 5 halves over here, because when we multiply 5 halves times 5 halves, we get 25 fourths for this little piece down here. All right, so we have x plus 5 halves is our factored form. It's going to be half of this middle term, and the square root of this is 5 halves. Okay, so this whole thing is going to be equal to x squared plus 5x plus 25 fourths, and it makes a perfect square. Okay, so what if we have some missing pieces now? And this is where it really matters for us. So if we have a square, quote unquote, that is missing something, okay, we want to define the area of the square as a binomial here, but we want to find the missing part. So first of all, let's find the current area. Well, we've got an x squared here, and we've got a couple 4x's. So altogether, we've got x squared plus 8x. And what is this missing area that we wish we had so we would have a complete square? Well, 4 times 4 is 16. So we wish we had 16 more. So 16 is what we're missing. That would give us x squared plus 8x plus 16, which is equal to x plus 4 squared. On this next one here, we've got a fraction length. Well, we know that this is x squared. We've got 7 halves x and 7 halves. If we take 7 halves and 7 halves, well, that just gives us 7 wholes. So we have x squared plus 7x when we add it all up there. And so what's missing? Well, down here we have 7 halves squared. That's 49 fourths. 7 halves times 7 halves. So 49 fourths is what's missing. Okay? So we have x squared plus 7x plus 49 halves. Now we want to notice this, or 49 fourths. Notice that this 49 fourths is just half of this 7 squared. Same thing over here. Half of the 8 gave us the 4, and we squared that 4 to get 16. So that's an important relationship. Let's use that.